Is 3.5 exponential and logarithmic models. So one of the things about pre-calculus is that you're going to do some pure math. So that's solving equations. That's actually like the last lesson we did, 3.4. It's pure math, okay? So solving equations, getting answers in exact form and rounded form. And then there's some applied math, okay? And that's what most of you guys are actually going to use. It's a really good thing to be able to learn how to interpret and understand data and different types of models. And what a model means is just fitting an equation to the data. So is it linear? Is it a line? Is it exponential? Does it increase rapidly? Is it logarithmic? So we figure out what type of model it is depending on what the data looks like. So here's an example of a data set for the height of a tree over time. So I'm going to go through and graph this on the TI-84. If you guys don't have a TI-84, you guys are going to have to learn how to use whatever tool you have available to you. So it can be done on different websites and things like that. If you can't find one that you like, maybe try getting a TI emulator on your phone or your computer, like I have. That's what I downloaded, a TI emulator. Okay, so first things first, in order to interpret any of the data, we have to input the data. So first thing is we need to read it and understand what our input value and what our output value is going to be. If I read this, it says that it's the height in feet and it's the time in years. Think about which one of those would probably be a good input value. I'm thinking that usually you want to input years, the number of years that something is around, and you want the output to be your height. What that means is my X value should be my years, the 1, 2, 3, 4, 5, 6. The Y value should be the height of the tree. So that's how I'm going to input it into the calculator. Second, how do I input it in the calculator? So most of the functions we're going to use today are under this stat key. So I'm going to hit stat, and there's 3 lists: edit, calc, tests. We're going to use edit and right now in calculator. If you click on edit, I already entered the data in. Okay, so go ahead and in L1, that's your X values, 1, 2, 3, 4, 5, 6. L2 are your Y values, 3, 6, 10, 13, 15, and 16. So go ahead and do that. Okay, and then a lot of students hit graph and they don't see anything. And so they get themselves confused and all kinds of other stuff. So on a test, I can't help you figure out your calculator. That's why we do homework, is so we can practice it, so you can get the keystrokes down. There's a process to this. So a lot of students hit graph, they get stuck right there, and they say, Mr. Up, I don't know what to do from here. So a couple of things. Number one, your window might be wrong. Maybe you're not looking at the correct part of the graph that we need to look at. However, if I look at my data, the ordered pair 1, 3 should be on there. And the ordered pair 1, 3 is showing on here, but it's not showing up. So that's a problem. The main reason that students can't see their data is because they didn't turn their stat plot on. So here's how you do it, okay? You go to there's a couple ways to do it. You can do it under stat. You can also do Y equals, and it has plot 1, plot 2, plot 3. Go up to plot 1, arrow up, hit enter, arrow back down. See how it's highlighted now? That means your plot is now on. So when I hit graph, there we go. Now I can see some points. However, I can't see all of them. There should be 1, 2, 3, 4, 5, 6 points, and I can only see kind of like 2.5. So what does that mean? That means my window is not right. First thing I notice about the data set is that all the X's are positive and all the Y's are positive. So I don't need all the negative parts of the graph. So I'm gonna show you how to set your window logically. So I'm gonna hit window, and my X min is now -10. The X values, remember, are your years. They start at 1. So even though I don't have a negative value on there, I am gonna put -2 on here. I'm gonna start at -2 so I can see the axis. The X value goes up to 6, so why don't we just go to 10? So -2 to 10 sounds good. Scale really doesn't matter. I'm going to make it 2. You can make it 1. It doesn't matter. The Y values, again, there are no negative values, but I am going to start at -2 so I can see the axis. The maximum Y value, height in feet, is 16, so we better go to probably 20. Okay, and again, a scale of 2 would be pretty good for this one. So regraph it and see. Now I can see all my data, okay? So first thing you want to do is make sure you can see all your data. If you get totally confused on the window, zoom works really well for stat plots. So if you hit zoom and then zoom stat, option 9, it'll find the data for you pretty well. Not always, but like 99% of the time, it really does work pretty well, okay? So first, does this look exponential, like exponential growth or decay? So does it rise very rapidly, or does it decay very rapidly and then level out? I'm going to say probably not. This one looks more like a logarithmic, where it rises very quick and then levels out. So this looks like a logarithmic graph, and what we're going to do is we're going to fit an equation to this using our regression features on our calculator. So how do we do that? What we need to do is we need to go back to stat, and this time instead of going to edit, we're going to arrow over to calc. Okay, so there's all this linear regression, quadratic regression. We've actually done it in this class before. You've probably done it in other classes. The tough thing for students is to figure out where logarithmic regression is. What they are looking for is LOG. So if you scroll down, okay, this guy right there, it's really tempting to do logistic. That is not logarithmic, okay? It's this one right here, ln. So remember, ln is your natural log. So we're going to do natural log. Natural log and log can be used interchangeably, okay? So natural log regression. So how I do that is I select option number 9. It's going to ask me these questions. Doesn't matter. Hit enter, 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 enter. Okay, and then it's going to come up with this equation. So you can decide where you want to round it to. The more decimal places, the better, the more accurate the graph is going to be. I'm going to go ahead and round it to 2 decimal places here. So this would be 2.06 and 7.70. And then the other thing it tells you here, which is handy, is the equation. So it has on the top there, y equals a plus b ln x. So I'm going to write that down. Y equals a plus b ln x. So it told me that my a was 2.06, and it told me my b was 7.7 or 7.70. Okay, and so that's what the function is. Okay, so let's go ahead and write that down formally. That's y equals 2.06 plus 7.7 natural log of x. So before you do anything, you're going to want to check and see if that actually does model the data well. So when I graph it along with the data points that I've already graphed, does it look like it matches up real well? So let's go ahead and go back to our graphing calculator. And this time I'm going to go back to my y equals, and I'm going to type that function in there. So that would be y equals 2.06 plus 7.7 natural log of x. And then I'm going to graph that along with my data. And it looks like it follows it pretty well. So it hits most of the points, and it has the general shape that I'm looking for. So that's pretty good. Let's go ahead and answer these questions down here. So what is an appropriate viewing rectangle? What that means is what are your windows? So remember that, actually we can go back and look, but remember we went from -2 to 10, scaled by 2s. So your x's come first, and then your y values went from -2 to 20 by 2s. So remember that x's usually come first and y's come second, so I'll just label them. Okay, so there's an appropriate viewing rectangle. And again, that's a really important skill. Depends on who your teachers were before, how much they emphasize moving around and finding those viewing rectangles. So how tall will the tree be in 9 years? So 9 years, years are your x values. So what this is asking you is to input 9 into your equation. So if I go back up here and see my equation, so I'm going to input 9 into my equation there. So grab your calculator. And go ahead and type that in. It's 2.06 plus 7.7 natural log of 9. Hit enter. And your tree is going to be approximately, let's see, 18.98 feet tall. And I guess let me just say this right now. What's the purpose of modeling data? One of the main purposes is to use predictions, okay? So you want to look at a situation and you want to see if you can extrapolate the data. So it's only been growing for 6 years. Can I tell how tall it's going to be in 9 years or 29 years? And we're going to talk about how good the model is here in a second. But 9 years down the line would probably be a pretty decent estimate. When will the tree be 30 feet tall? So this is one of the ones that you can solve a couple different ways. So you can use a table to solve it. I'm going to go ahead and solve it mathematically. So when the tree is going to be 30 feet tall, that means your y value is 30. So you would set up the equation 30 equals 2.06 plus 7.7 natural log of x. And then you go ahead and solve that equation. So you'd move the 2.06 over by subtraction, you'd divide by 7.7, and what that gives you is 3.62855714 equals natural log of x. And then you would change it to exponential. So it's in logarithmic form right now. Remember, it has base e, so it's e raised to the 3.62855714 equals x. So why did I use so many decimals? When the exponent has that many decimals, just a few decimals can really throw off your answer there. So again, this is solving it mathematically. If you want to use the table, you can, but you're going to get approximately 37.7 years. Okay. This question right here, I really like this question because one of the things about understanding data, you guys are going to see data in all kinds of your real life situations when you get older. Some of you guys are going to use different type of data sets and looking at data for your job. Some of you guys are going to just need to know it for reading the news and being literate as far as the media goes. There's so many people who publish graphs and then draw the wrong conclusions in newspapers or out there in the media. And it's because they don't understand really what they're looking at. So a lot of times newspapers are written at like a 10th grade level. This stuff is more complicated than a 10th grade level. So you should have a better understanding of like being able to analyze situations and make decisions for yourself rather than rely on somebody else to tell you about the data, okay? So is this a good model for the situation? Why or why not? So I want you to think about this, okay? So let's go back to the graph here real quick and see what that graph looks like. Okay, that graph right there, remember, it goes infinitely in both directions for that equation. So it's going to go infinitely low, and it's going to keep continuing infinitely to the right and infinitely high. So does that make sense? I think for the window we're on right now, it's pretty good. However, I kind of worry about this piece right here, okay? What does that mean? That means like at like about 0.1 years, the tree had negative growth. That doesn't really make sense. I mean, I guess you consider it being a seed in the ground, but it doesn't go infinitely negative. And also, does the tree grow infinitely tall? Because if you go throughout the years go to infinity. So does it live infinitely long? And does it also grow infinitely tall? I'm going to say no. So a lot of times models are good for a particular range. So maybe from like a half a year to like 30 years, this is a really good data set. But after 30 years, maybe this particular species of tree dies. So it isn't a great model for like 100 years if the tree actually dies at 30 years, okay? So those things, when you're looking for how good a model is, you're going to want to look at really small values, negative values. You're going to want to look at really large values to see the end behavior of the graph. In this case, the end behavior is where the model falls apart. Do you think it's a good model for the situation? Between 0, so when x is less than like 0.5, it's no good, okay? Can't have negative tree value. I said value, I meant height, okay? And also, trees don't grow infinitely tall and they don't live infinitely long. So it could be a good model for a specific range, but maybe not when we're looking at end behavior. Okay, so that's an example of how to model data, how to use your calculator for the regression models. You're also gonna have several problems like these next couple here on the test. It says an investment of 400 increases to 890.20 in 16 years when compounded continuously. Find the interest rate. So first thing is these keywords right here. Compounded continuously means we're going to use the PERT formula. So let's go ahead and write that down. P equals, A equals P times E to the RT. Okay, and we're going to plug things in. Initial investment is your P, so your 400, and then E to the R times T. We don't know what our rate is. We do know what our time is, so that's 16. And we know how much we make. We got 890.20. So why is this in this particular section? Because this is modeling some information about the compound interest formula, and we're trying to solve for the exponent. When we're trying to solve for the exponent, we should be thinking, all right, I need to take the log or the natural log of both sides. I'm thinking I'm going to take the natural log because that E. So anytime you see a base E, you're going to want to think natural log. So in order to do this, I need to move the 400 over first by division. So divide both sides by 400. Okay, so we have, I'm just going to write it out like it's written now, 890.2. You don't have to add that x plus 0 over 400 equals e to the 16r. So remember, at this point, you're going to take the natural log of both sides to move the exponent down. So I'm going to do both steps. I'm going to take the natural log and move the 16r down. So we have natural log of 890.2 over 400 equals 16r natural log of e. Now, the reason that this works out nicely is because natural log of e is just 1. So you can type it in your calculator if you want to, but it's 1, so it ends up going away. And then the last step I have is to divide by 16. Divide by 16. Now, again, I like to do it all in one shot. You could have done the 890.2 divided by 400, got a number, but then you're keeping track of a bunch of decimals and all that other stuff. I like to fully solve first, get this whole chunk, and then plug it in the calculator. So when you plug that whole chunk in your calculator, you're going to get R is approximately 0.05. So what does that mean in the context of this problem? It asks to find the interest rate. So 0.05 would be approximately 5% interest. Okay, so there you go. This one, there's a couple problems like this on the test too. It says an investment is continuously compounded at a rate of 6%. Find how long it takes the investment to double. So here's the key thing for this. This word, well, a couple key things, I guess. Continuously compounded, so we needed to use that same formula. So we talked about that previously. This is the important part for this problem. How long does it take for it to double? Some students are going to get confused because they think there's not enough numbers here. So there's a couple things you could do, okay? You could pick your own initial and final amount. So pick anything that doubles. Say that I'm going to pick, so let's just do this, A equals P times E to the RT. Say that I'm going to pick, I have an initial amount of 10. Okay, if I have an initial amount of 10, that means when it doubles, it's going to be 20. So 20 equals 10 e to the RT. Okay, say that I have an initial amount of 4. Then it would be 8 when it doubles. 8 equals 4 e to the RT. The reason I'm doing both of these is because they both have the same first step. I'm going to divide by 10, divide by 10. I'm going to divide by 4, divide by 4. And you guys notice 20 divided by 10, 2 equals e to the RT. And 2 equals e to the RT. It doesn't matter what you start with. So you can pick one. If you get yourself confused, just pick a starting value. 10, and then it doubles to 20. 10, and if it says it triples, use 30. Okay, so you can do that, or you can just jump right down to this line here. So 2 equals e to the RT. It says it's compounded at a rate of 6%, so my rate is 0.06. And it says find how long, so that's my t. So at that point right there, I'm going to go ahead and take the natural log of both sides because I want to get my t down as a coefficient. So I have natural log of 2 equals 0.06t ln e. Same thing as last time, that natural log of e is just 1. and then you divide by 0.06 to move this to the other side. So in my calculator, I'm going to type in natural log of 2 divided by 0.06, and that's going to give me that t is approximately 11.5 years. Okay, so there's my answer for that one. One more quick problem. The next page here. So going back to half-life again, it says a certain substance decays according to the formula Q of t equals Q sub 0 e to the negative 0.035 t, where t is the time in days. Find the half-life of the substance. So this one is very similar to the last one. It doesn't give you a starting amount. It doesn't give you a final amount. So you could pick your starting amount. Say that I pick my starting amount as 10. My half-life would be when half of it is left as 5. Okay, again, when you move that 10 to the other side by division, you should recognize that you're going to get half, because it's half-life, equals e to the negative 0.035 t. So I'm going to do the same thing as last time. Take the log of both sides. I'm going to drop the exponent. So I have natural log of 1/2 equals negative 0.035 t. Natural log of e, again, same thing as last time. It's nice because natural log of e is 1. And then divide by negative 0.035. Divide by negative 0.035. So in your calculator, you would type in a natural log of 1/2 divided by negative 0.035, and you're going to get that t is approximately 19.8 days. Okay, so a few different real-world application problems. We started with a modeling problem, modeling data, and both of which are probably more applicable to your guys' real adult life than a lot of the other areas of pure math in this class. So if you're going to learn one thing about how to interpret and understand and solve equations, this would be the section. Okay, so that's it. We're done.